right, so for calculus today, all I want to do is go over some answers to page 475. I looked at everybody's. It didn't go well for a lot of people, so I want to look at those. So 475, 1A and C were the two that I had questions on. So for 1A, it says 5,000 equals 4,000 times 1 plus 1.0.075 to the n. So I would divide this side by 4,000, and I would divide this side by 4,000, which would give me 5 over 4 is equal to, now this is in brackets, so I think I would just add those, 1.075 to the n. Now what it wanted you to do was solve for the variable, in other words, figure out what n should be. So I would personally change this to logarithmic form. So log of base 1.075 of 5 over 4 is equal to n. So again, the shortcut, when you have log that's not in base 10, you do log of 5 over 4 divided by log of 1.075. So if I do log of 5 over 4, and then I put divided by log of 1.075, I get 3.1. It's like 3.08. All right, that's 1A. The other one that I had was 1C. So 1C was 8,500 equals 5,800 times 1 plus 0.0875 over 4 all to the 4n. So again, first thing I would do is I would divide this side by 5,800. So I would divide this side by 5,800. So I would have 8,500 divided by 5,800 as 1.4655, and it keeps on going. That is equal to, I would actually do this inside 0.0875 divided by 4, add 1 to it. 0.0875 divided by 4, add 1 to it. It's actually 1.021875 to the 4n. So same as last time, I would change this to logarithmic form. So log, base of my exponent becomes the base of my log. My answer is what I'm taking the log of. And that's equal to 4n. So I would do log of this divided by log of this, and then I would just divide by 4. So I would do log of 1.4655 divided by log of 1.021875, which is like 17.66, and I would divide that by 4 so that I get n is 4.4. Now I have not checked these, so just bear with me while I look at the back of the book at page 475. 75, there we go. 1A they said was 3.08, which is what I had said. C, they're saying 5.97, and I got 4.4. So, wonder what I did. Because they're saying 5.97, I'm saying 4.4. I don't know, I rounded this off. I don't know if that has anything to do with it. Let me see. Log, and I'm gonna do this, of 8,500 divided by 5,800. And then I'm gonna divide that by log of 1.021875, and then I'm going to divide that by 4. Okay, I still get 4.4. Maybe the answer at the back of the book is wrong. Maybe I'm doing something wonky. Oh, I know why. Because I mixed up. You're probably yelling at me now, right? Because I wrote down part of C and part of D because I'm good like that. So you're probably yelling at the screen going, why is that crazy person doing that? So it's actually 1.065 over 2 to the 2n. Same process though, okay? Same process, just do the same thing just with those numbers instead. That's what I did wrong. Number two, you have a cup of hot chocolate with a room temperature of 21 degrees, so that is the surrounding temperature. And it cools according to Newton's law of cooling. Determine the rate of cooling, so we're actually looking for K. Of the hot chocolate, if it cools from 86 degrees Celsius, so that would be like my original temperature, down to 65 degrees Celsius, so that would be like my final temperature is 65, in 15 minutes. My time is 15 minutes. So you can leave it in minutes if you want. It doesn't have to be in hours. So my formula is T minus TS is equal to TO minus TS, E to the K times T. That is Newton's law of cooling. So basically the same as everything else. It's just you subtract the surrounding temperature from your other temperatures. So my final temperature is 65. My surrounding temperature is 21. My original temperature of my hot chocolate when I poured it into the cup was 86 degrees minus the surrounding temperature of 21. E to the K, which is what we don't know, times T. So 65 minus 21 is 44. 86 minus 21 is 65. E to the 15K. So I would divide this side by 65 and this side by 65. So I have 44 divided by 65, which is 0.6769, it keeps on going, is equal to E to the 15K. I would change this into logarithmic form, but when I do, the base of my log is going to be E. That actually means ln of 0.6769, on and on and on, is equal to 15K. So then I would just divide both sides by 15. So I'm going to do ln of my answer divided by 15. I get negative 0.026. And what that means, it's negative because it's cooling off. The temperature is going down. And that would be 2.6%. So it cools down by 2.6% every minute because we did our thing in minutes. And for number 2, oh, Wicket, that's not a chew toy, don't chew on it. For number 2, that's exactly what they got as well. All right, Just a second, I gotta grab that before dog chews it. My apologies, Wicket. Yes, you get that. I'll get this. Okay. He's got a chew toy, and as soon as that rolled by him, he was gonna grab it, chew on it instead of his chew toy. That wouldn't have been good. All right. So that was number 2. The next question I had was number 3. I'm pretty much doing all of them, just a heads up. Number 3, a population of termites is increasing according to the exponential growth and decay formula, which is that. Determine the length of time, so we're looking for T, that it takes this population to triple. So we're looking for triple. If its initial population is 1,800 and it doubles every 0.035 days. So I know why you struggled with this one, because you tried to figure out K right away, or sorry, T right away, and you can't. If I were to figure this, if I were to put this in, my original population is 1,800, and they want to know how long does it take to triple. So 1,800 times 3 would be 5,400. How long does it take to go from here to here? The problem is I don't know what K is, and I don't know what T is, and I really can't have two unknowns. That's why they give you what seems to be extra information, which is that the population doubles every 0.035 days. So let me just go over here for a minute. My population doubles, so if it starts at 1,800, it doubles. 1,800 times 2 is 3,600. E, and I don't know what the K is, but I do know the time. It's 0.035 days. So I'm going to divide this by 1,800, and I'm going to divide this by 1,800. So I have 2 is equal to E to the 0.035 K. So I would change that into logarithmic form. So the base of my log would be E, so that means it's ln. Ln of 2 is 0.035 K. So that means my K is whatever ln 2 is divided by 0.035, which gives me, that doesn't make any sense. Hold on. Ln 2 divided by 0.035. All right, I'm getting 19.8 as my K. What that would mean is that it is growing by over, let me see, by over 1,980%, right? Because this is actually a percentage. So it's growing by over 1,000, almost 2,000% in a day. What are we talking about? Termites? Ew. Okay. So now let's go back here. Now I can fill in that my K is actually 19.8. So if it doubles in 0.035 days, 0.035 days is not very much, right? That like 0.035 of a day, that's not much. So we can solve for T now, because we can divide this side by 1,800. So we can divide this side by 1,800. So we have 3 is equal to E to the 19.8 times T. So again, change this into logarithmic form. This would be ln 3 is 19.8 T. Divide both sides by 19.8. So ln 3 divided by 19.8 is 0.055 of a day. Well, that kind of makes sense based on that it doubles every 0.035 days, so it'll triple in 0.055 days. That basically is an answer that makes sense. based on the information given to me. So again, I'm going to check my answer, although my bookmark is now gone. Get another bookmark. So 0.0555 days, yes. Okay, so I got that one right, yay me. All right, the next one is number 7. People had lovely little notes written to me on their work for this one. Number 7. Let's see if I can answer those questions that you left me. So, a piece of steel is going to be forged into a turbine. So they have this piece of steel. They're going to put it in a forge, which is basically a big giant blast furnace. They're going to melt it down and they're going to shape it into the shape of a turbine, like a propeller, like something that turns. My husband actually, there's a big giant turbine in the bottom of the Bay of Fundy near the rocks, on the way down to the rocks actually, because they were going to try and harness the tidal bore power to turn that into electrical power. Turns out it didn't work, and so now there's this big giant millions of dollars worth turbine sitting at the bottom of the Bay of Fundy, and it doesn't work. All right, so that's just my little aside, just so you know, our government dollars at work. The steel is held in a furnace, and the furnace temperature is 1,250 degrees Celsius. That would actually be the surrounding temperature. When you put this steel in, it's now in a surrounding of 1,250 degrees Celsius. Once it's taken from the furnace, it can be worked until it reaches a temperature of 1,100 degrees Celsius. So working with metal, working with glass has similar properties. My cousin is a glass blower, so what he does, used to be, he doesn't do it anymore, still has all the stuff though, but what he does is he heats up his furnace, he takes a big thing of glass, melts, basically glass shards almost, melts it all down on the end of a pipe, and then he, once it's all melted, he brings it out, and there's this big glowing mass of glass at the end of this long pipe, and he can work with that. It's malleable enough at that temperature to work with. Now he only has a few minutes to work with it before it gets brittle enough that it will break, and so he has to work with it as long as he can, and then he has to put it back in the furnace to soften it up again, to bring it back out to work with it again, and he has to keep repeating that process over and over. This would be very, very similar. So after this time, it becomes too hard to forge successfully. Experiments have shown that the relative cooling rate for this grade of steel is about 1.4% per minute. So my K is 1.4% per minute, but you can't use that as a decimal. You have to change it. So that'd be 0.14. Now remember that it's cooling, so my K would have to be negative because it's going down, okay? So you're losing about 1.4% of heat every minute. Suppose that the temperature of the forge shop is 30 degrees Celsius. Okay, so I was wrong about the surrounding temperature because we're talking about it after it's out. The surrounding temperature is actually 30 degrees Celsius. This is actually the original temperature because when you take it out of the furnace, it's at the same temperature that the furnace was. Determine the formula for the temperature of the steel T minutes after it's taken out of the furnace, and how long can the workers forge the steel before it has to be returned to the furnace. So again, the formula is T minus TS equals TO minus TS e to the K times T. So let's fill in what we know. The final temperature that we can work with it at is 1100 minus the 30 degrees surrounding temperature. and that's equal to my original temperature, which it would be the same as what the furnace was because you're heating it up to that same temperature, minus my surrounding temperature, which would be 30, E, now my K is negative 0.014 times T. So when it asks you what the formula is, there it is. We're going to clean this up and solve for T. So 1100 minus 30 is 1070 is equal to 1250 minus 30, which is 1220 e to the negative 0.014 t. So I would divide both sides by 1220, so 10,070 divided by 1220 is 0.877, and it keeps on going. That's equal to e to the negative 0.14 t. Change this into logarithmic form. Again, my base of my log would be e, which means I'm doing a ln. So ln of 0.877 equals negative 0.014 t. Divide both sides by negative 0.014. So I'm going to do ln of that divided by negative 0.014. I get 9.37. And again, our time was measured in minutes. So you have less than 10 minutes to work with that steel before it becomes too hard to work with. And I'm just double checking. Number 7, I'm just making sure I have the right answer. Yes, I do. Yes, I do. All right. They have a slightly different answer for part A, but I'm happy if you leave it here or here. Both of those would be fine because you've just simplified both. Okay? The last one I'm going to do, and you have no work to do today. Today is just an answer video, and that's it. So you can go have a nice weekend. Hopefully, I think it's supposed to be nice and sunny and warm. I hear you guys went and looked at the sunrise yesterday. Crazy people, why are you up at sunrise? Go watch the sunset. Looks exactly the same, but happens at a better hour. All right, number 10. Number 10. You just had to do A. Thorium-234 has a half-life of 25 days. So half-life of 25 days. How long would it take for 30,000 grams, so that is my original amount, 30,000 grams, of thorium-234 to decay to 500 grams? This is very much like number 3 was, okay? So if I know the formula is P is equal to POE to the K times T, and my original amount, I started with 30,000, and I end up with 500. The problem is I want to know how long, I want to know T, but I also don't know a K, which is why they tell you that the half-life is 25 days. So again, down here, just off to the side, half-life means if I start at 30,000 grams, it will take 25 days to break down to 15,000 grams, because that's half, right? So if I divide both sides by 30,000, I end up with 1/2 is E to the 25K. By now you should hopefully be seeing the pattern. We're going to change this into logarithmic form. So we have ln of 1/2 is equal to 25K. Divide both sides by 25. So ln of 0.5 divided by 25 gives me negative 0.0277. That is my K. So I can now put that into here, negative 0.0277. So I know it takes 25 days for it to decay down to half of what it was. This is a lot less than half, so I should end up with a lot more than 25 days. So I'm gonna do 500 divided by 30,000, and that gives me 0.01666, and it just keeps on going, is equal to e to the negative 0.0277t. Again, by now you should be seeing the pattern. Change this to logarithmic form. Ln of 0.01666, keep on going, is equal to negative 0.0277t. So I'm just going to divide both sides by negative 0.0277. So I'm going to do ln of my answer divided by negative 0.0277, and I'm getting 147.8 days. Again, much more than 25 days. All right. That's it in terms of answers. Have a good weekend. On Monday, we're going to start into the very last section that we're going to be doing. Okay? Talk to you again soon. Enjoy the sun.